Hello friend. Today we'll start the new unit 3. So in unit 3 you have first topic as unit load method. So this method typically used to find out the deflection in truss. Even we can use this method for other type of structure like beam, frame, but here in your syllabus we have this structural deflection of trusses. So using this method we can calculate deflection of any given joint or the desired joint in particular direction. So to solve this problem using unit method, first what we have to do, we should know how to analyze a truss, and you have determinate truss only. So like here we will be discussing only determinate trusses, so no indeterminate structure at present. So deflection of joint of determinate truss using unit load method. So what we'll be going to discuss here is first we'll review how to analyze a truss, though we already discussed this topic several times. I think first semester we already discussed how to analyze the truss, so you should know exactly how to analyze a truss. Still we'll revise it. Actually in unit load method we have to analyze a truss or determinate truss several times. So like what you did in first semester, like you solve the truss only for one time, but here same truss you have to solve it for two or more than two times, depending upon the deflection number of deflection component we want to calculate. So first we will review this truss analysis, so how to solve determinate truss, that we'll discuss, and then next we'll find out deflection of joint. So there can be three reasons. One, due to external load, which is like a predominant case. Second, due to lack of fit. So already we discussed when some member is like too short or too long, that cause lack of fit and it causes additional stresses in the structure or additional deflection in the structure. And then due to temperature change. So these three things we'll discuss. And because of these three reason, what will be the change change in the deflection, or whatever will be the deflection, that we'll discuss, right? So first topic, review of determinate trusses. So how to analyze determinate trusses, that we'll discuss. For this typical problem we need cross-sectional area. So that cross-sectional area is given 1000 mm square, and Young's modulus is given 2 into 200 kilonewton mm square. So this is the given truss, which has like say point load of 100 kilonewton at D joint, and remaining geometry you can see this is like a truss having all angle of 60 degree. So all member will have same length, or each triangle is equilateral triangle, right? So since we have already discussed this topic in first year, that time also I told you we can solve this truss by 4 steps. So first step is we need to determine whether the given truss is determinate or not, and that we can do using 2j minus r. No doubt for your syllabus mostly you will get determinate trusses in exam, but still you need to prove that the given truss is determinate truss. So the equation that we use is 2j minus r equal to m, which is like very famous, you already know that. Then second, reaction calculation. So this can be done by using equilibrium equation, right? So we'll be using equilibrium equation to calculate the reaction, that you know, like we have solved several problems in which we calculated the reaction using this equilibrium condition. Third step, member forces. We need to calculate member forces, and this calculation can be done by two methods, section method and joint method. So here I'll be discussing joint method, since most of the students feel it is little more easy compared to the section method. No doubt section method it's little like a fast method, you can arrive to the result very by taking particular section, but joint method is little, I feel little lengthy. but it is little easy as well. And then finally, very important, finally you have to write down the force table. So you have to write down member name, the force in the member, and then type or the nature of the force, whether it is member is under compression or tension. So this particular truss like we'll calculate like a first step we'll do, in which we'll calculate. So like here number of joints are like 5, reaction components are 3, that is one horizontal, one vertical here and one vertical here. So 1 2 3, number of reaction components are 3, and m, number of members, so 1 2 3 4 5 6 7. So like we have 7 member. Now if you use this 2j minus r, that is 2 into j 5 minus 3, so 10 minus 3 7, which is equal to m. Hence the given truss is perfect truss or determinate truss, right? So we can solve this truss using equilibrium condition. So you should not worry about indeterminate structure, since you do not have that in this semester, right? So next topic is like reaction calculation. This is steps 2, right? So reaction calculation, we typically use these 3 conditions of equilibrium: summation fx equal to 0, summation fy equal to 0, and moment. We take moment about certain point and we tell that that moment is, or summation of the moment to all the forces should be equal to 0. So we'll use this 3 equilibrium condition. So first condition, summation fx will give you ha equal to 0, right? So you can, I hope it is like visible. Okay, so like here summation of all horizontal force is equal to 0. There is no any other horizontal force, so therefore this ha should be 0. The next summation fy equal to 0, so addition of all the vertical force should be equal to 0. So like here you have this one vertical force, external load, and these 2 reactions. So like here, that's how VA plus VB equal to 1000. Then finally we'll take moment about point A and we'll equate to 0. So if you take moment about point A, there won't be moment due to these 2 forces or this 2 reaction, since the line of action of these 2 forces are passing from point A itself. So there won't be any moment due to these 2 forces. Now next force is this 100 kilonewton. So 100 kilonewton, it is passing from the midpoint, so 100 into 2, and it will cause which direction? It will cause like clockwise moment, right? And then this moment due to this VB force, so like this distance is 8 meter, VB multiplied by 8, and it will cause anti-clockwise moment. So if you compare clockwise and anti-clockwise moment, you will get VA equal to 25 kilonewton, and again you substitute here and you can calculate VA, which is like 75 kilonewton. So VB is 25, VA is 75 kilonewton. Now step 3. This is lengthy step, since we will be solving each joint, right? So first we should able to draw free body diagram of joint. So like we should start from the first joint. So whenever you select a joint, you should remember one thing: there should not be more than 3 unknown at that joint. Why? Because we can only use these 2 equilibrium conditions, so there should not be more than 2 unknown, or in other word, like each member has one force, right? Each member will have one force, so there should not be more than 2 member whose force we don't know, right? So if there is third more member, but then we should know the force in that member, then only you can solve that joint, otherwise you cannot solve. So like here we are considering joint A, like this is joint A, right? So we are drawing free body diagram of this joint A. So no doubt I have calculated, that's how I written this value. But then like if you see, this horizontal force is unknown, this inclined member force is unknown. Again, the most important point here is like if I am showing it away from the joint, right, this is joint A, and if the direction of force is away from the joint, then we consider that as a tensile force, whereas if it is towards the joint, then we consider this as a compressive force. That is what here I have mentioned. So like if the force is away from the joint, then it is tensile force. If they are towards the joint, then it is compressive force, right? So then we'll use this two equilibrium condition to find out the force in each member, right? So we have these two unknown forces. So if we use first condition, that is vertical force equal to 0, then we have this vertical force, this vertical component, this horizontal component. So like only vertical force, so this two component will come, this vertical and this vertical. So from that you can calculate Vd equal to 86.8 kilonewton, and since it is towards the joint, no doubt before you solve I am assuming this two direction. Right. So like you can assume it away from the joint, you can assume it towards the joint, and if you are like when you calculate, if you get positive answer, then the direction whatever we are assuming, that is correct. Or if we get negative answer, then you have to change the direction. So since we got positive answer, that means whatever the direction we have assumed, it is correct, right? Since then like Vd like 86.6 kilonewton towards the joint A, therefore it should be a compressive force, right? It should be a compressive force. Generally we write down compressive force negative and tensile force positive, that we'll see later. But just here what is more important is like it is compressive force, and like it is 86.6 kilonewton. Now if you use second condition, that is summation Fx equal to 0, then how many horizontal force we have? This HA is there, but anyway that is 0. Then second, this horizontal force AC and this horizontal component of AD, which now we already know, right? So horizontal component will be FAD cos 60. Since this angle is 60, so this angle will also be 60 degree, right? So this is adjacent side and this vertical is opposite side. That's how this vertical component is sine and horizontal component is cos. So if we use this summation Fx equal to 0, what we'll get is FAC is equal to FAD cos 60. So already we know this 86.6 kilonewton. So you substitute that and you will get 43.3 kilonewton. Since this answer is also positive, so whatever the direction we have assumed is correct. So since the direction is correct, which is like away from the joint, that means it should be a tensile force. Away from the joint A, that means it is tensile force. So this is very important that you should remember that if force is away from the joint, then we assume that it is tensile force. If it is towards the joint, then it is compressive force. This is the first thing that you should remember. And second thing, before we solve, we are assuming this direction. So if your answer is positive and whatever, then it indicates that whatever the direction you have assumed is correct. If answer is negative, then like whatever the direction you have assumed, that you need to change, right? But since this compressive, this tensile that I have assumed, and both answer luckily I got positive, that means whatever the direction I have assumed, they are correct. So this is how like you can solve the joint. Now next, similarly you can solve like other joint. Now this is joint D. So in like a truss, this is joint D. So at the joint D we have this vertical force of 100 kilonewton. There it is. Then there will be some force in this member. So now here like when we have drawn like free body diagram of A, that time what are the force we had in this member, that we have written like force AD. Now when you are showing free body diagram of joint D, that time we will be representing it by FDA, right? And these two should be equal because they are like in the one member, what are the internal force that is acting, that we are representing. But exactly what it represents, it represents the force that is acting on the joint by this member. and since this member is under tension, so it will apply same force, right? So then, like here, we already calculated force in AD member is compressive. That's how this force should be like towards the joint. Again, you can resolve it into two components. This angle is 60 degree. All members are having like an angle of 60 degrees, so there is less confusion here, right? Now, this is like member DC, this member, right? So this member we are drawing like a free body diagram of this portion, right? So then this is that VD. Next, again you can resolve it into component. This is horizontal force. This all direction we are assuming, no doubt this we know, but for this two member we are assuming this two direction. Second thing, like here if you see there are three member, right? And I told you there should not be two unknown force, internal force member, but here we have three member. Out of these three we already know the force in this member, so unknown is only in this two, hence we can analyze joint D. If it is more than two unknown, then we cannot solve it, since again we have only this two equilibrium conditions. So again you use this two equilibrium condition, like already I have written here. So if you solve that, you will get force in this two member, DE and DC member. Again, as a standard practice, always have practice to write down like what are the number you get in calculation, that you should write down in the figure. Why? Because if you solve it like more number of joint, then it is difficult to check those number always in calculation. So have a practice to mention that in the figure. So in figure it is easy to like observe those numbers. Similarly, then joint like no doubt immediately you cannot solve joint C. Why? Because you don't know the force in this two member, right? Maybe you can solve it. Why? Because like I have solved like first this joint B and then joint C, but even you can solve it, as you know already the forces in this two member and unknown will be this two, so you can solve it. But I solve it like first joint B and then joint C, right? So you use again two equilibrium condition here and you will get the forces. Then finally like you solve the joint C. When you solve joint B, that time itself you will get force in BC member. So unknown will be only like CE member, right? So that you can solve using any one condition, that is summation Fx equal to 0, or even if you use summation Fy equal to 0, then also you will get the answer, right? So then we calculate all the forces, and then finally this is step 4. So in step 4, finally you have to write down this force in the force table that you have to write down. So member, force and their nature. But for this problem what we are discussing, unit load method, in that definitely this table is not sufficient. There is some modification in this table that we'll see little later, right? But if you are just solving a normal truss and if you want to find out the forces, then this table is mandatory, right? But since we are doing little more than that, so we'll have little modified this table. I'll show you that little later what is that table is. Now next, how to calculate deflection. So this was like a review of how to analyze determinate truss. Now we'll discuss exactly how to calculate deflection using unit load method. So to like for example, we'll take the same truss, right, and we'll try to calculate vertical deflection of this joint D. So because of this load, this joint D will deflect down, right? So we want to calculate that deflection. So I'll keep just here so it will be easy for you. Okay, otherwise I have here anyway. So like to calculate deflection, this is the equation that you should remember. No doubt it is very easy equation. It like what it tells, summation PKL by AE. So few terms you already know, like A is a cross-sectional area, E is Young's modulus or modulus of elasticity, L is the length of the member, only two things, that is P and K, they are having some typical meaning. So here you should remember very carefully, P is the member force. Like you like we already calculate that member force due to external load, right? So we have to calculate force in each member, right, due to this external load. So here we have only one external load. Even if there are more, then you should consider all external load. You should analyze that truss like what we did just now, and then you should calculate force in each member, which we already calculated here, right? So like you can use this is what is like a P. This table is nothing but like a P force, right? So for each member you should calculate this P value, right? Some books instead of P they write it F, so you may get instead of P the letter F. Now this K, so what this K is, now you should remove this all external load, right? You should remove all, like for example here you again it is only one force, so you remove this one force and then you have to apply a unit load in the direction where you want to find out the deflection. For example, here we want like a deflection at C point, and that too vertical deflection, so we should apply unit load at C in downward direction. So downward or upward you can take any way. If your answer is positive, then the direction is positive. For example, here it is well expected because of this load this is going to move down, so we should consider downward load. But if you consider by chance, if you consider upward, then you will get negative answer, right? So if it is negative, then whatever the answer you get, that answer is correct, only direction that you need to change. So then you remove this force, right, this like 100 kilonewton force or external force, and then apply unit load at point C. Again, unit of this 1 kilonewton is unit of this unit load is kilonewton. Why? Because here in actual problem unit is kilonewton. So if it is in Newton, so you apply Newton, 1 Newton force, but since here it is in kilonewton, so you also apply it in kilonewton, right? So then K is the force because of this 1 kilonewton in each member. So like here we calculated the force P in each member due to this external load. Similarly here we have to calculate force in each member due to this 1 kilonewton, right? So due to this 1 kilonewton we should calculate the force. So this is given truss with external applied load, and this is like truss with unit load at point C. Why C? Because we want to find out like vertical deflection at point C, so you should apply vertical force. Say by chance in your problem if it is asked to find out horizontal deflection of joint E, that time you should apply horizontal force here. Since we want to calculate vertical deflection, so we are applying vertical force. So if you want to calculate horizontal, then you have to calculate horizontal force. Again, remember here, so like in some problem it may ask to find out horizontal and vertical both. So what you have to do, you have to calculate K1 and K2. So K1 will correspond to 1 unit load along horizontal direction, and K2 will represent the internal force in the member due to vertical force in other direction, right? So that, and again that time you have to solve the same truss for third time. Here we will be solving it for 2 times. One because of external load to calculate this P, and second time like to calculate this K, we'll take this truss, we'll analyze it, and the force in each member will be our K. So like if you want to calculate more like deflection, that's how I told you should apply more like unit load in that particular direction. You solve the truss and you'll get K1, K2, K3 like that. So for each deflection you can use same equation only, like to find out like horizontal. If you want to find out horizontal displacement, here you apply like unit load, you calculate and say that all forces are like a K1 forces, then vertical you apply here, and then calculate the forces in each member, and that will be like your K2. So to calculate horizontal deflection, in this equation you use K1. To calculate vertical deflection you should use here K1. Remaining things will be as it is. Now hence, to find out the vertical deflection at C, we have to analyze the given truss for 2 times, right? One for given load and to calculate P, member force due to external given load, and second time again we have to analyze the truss by applying a unit load along the vertical direction at C. Why vertical? Because we want to find out vertical deflection at C. To find out K, member forces due to unit load only, so there won't be any external load. We have to consider only unit load without any external load, right? Now we have already analyzed this truss for external, that 100 kilonewton load, so I am not going to solve it again since we have already solved that, right? But I have to solve it for second time to calculate K, like K values in each member. So to calculate that, again it is same procedure that what we have to do, what we did, but only change is that this time we should not calculate whether the given truss is determinate or not, because we have already calculated. So we should not do that, but then from second step, which will be like here first step, that is calculating reaction. So definitely load has changed. Initially it was like 100 kilonewton, now it is 1 kilonewton at C. Initially it was at point D. So definitely these reactions will get changed, right? So therefore first we need to calculate reaction, then second step we have to calculate member force, and third step is force table. This force table will be different. What we have saw, there will be change. I'll tell what will be the change in that force table. So then we'll use this two equilibrium condition. We'll use these two equilibrium conditions to calculate the reaction in each member. So like from symmetry itself you can say that half load will get here and half load will get transferred to this two end, right? So it is 1 kilonewton, so it should be 0.5 kilonewton here, 0.5 kilonewton here, but opposite in direction. But that you have to calculate in exam. You cannot just write that, you should calculate, because this step will have some marks. So if you are not writing this step, then you may lose the mark. So better you write down the steps. So next like again we will start from the joint A, right? Again here half kilonewton vertical, half kilonewton force is acting. So accordingly, like you use this two condition of equilibrium and you solve it, you will get the forces. Again I am assuming these are the assumed direction, and since we got positive answer, that means whatever the direction we have assumed it correct. And since though it is positive answer, but it is towards the joint, and this is also positive answer but away from the joint. That's how this is tensile, this is compressive. So when you will write down the final force table, in that force table, though these two are positive value, but we have to consider this tension and compression nature, and based upon that we have to give plus and minus sign, right? But here this only tells the magnitude and the direction. So this like and again there is one more change. Instead of writing like F, I am writing here K, just to have like difference between FAD and FAD is because of, or like PAD is because of the external load, and KAD is because of the unit load, right? So again we can solve like a joint A, joint D, but here again we should not solve whole truss. Why? Because this problem is a symmetric problem, right? So if you know all the forces in this member on this say left hand side, so all forces in right hand side will also be same. That's how I have solved only this two joint A and D, and from that I can write down force in other member because of symmetry. since all loads are symmetric, all geometry of the truss is symmetry, so directly we can write down. Otherwise we need to calculate this all forces if your truss is not symmetric in geometry, or even if loads are not symmetric on the truss, right? But here, since the load and the geometry both are symmetric, so we can directly write down these forces. Now finally we have to use this equation to calculate deflection, right? So like if you see in this equation, what we need is P, what we need is K, what we need is L, what we need is A and E. So typically your table should have column for each of this value, but since E is constant, so we may not need to write down. For this problem, even A and L are constant, so we may not need to write down. But another problem, this value may change, so in that case you need to write down those in a column as well, right? The most important part is this P and K, right? So you should have one column for P, another column for K, right? So this is how you should write down it. So like first is member name, second is length, third is cross sectional area, then P, then K, and instead of like PK, actually you should calculate PKL by AE. But since like here some values are constant, these values are constant which will come out of the summation, that's how I haven't written here. But otherwise you should do this calculation and your final column should be for this one. But since for this typical problem, like cross sectional area E and L are constant, that's how it may not be required to write down this value or this calculation, because that component we can directly multiply, right? So then AD, DE, all the member, then their lengths, no doubt they are same. Cross sectional, again they are same, but if they are different, then you should write down here. Then P, this is what is important. The member AD, it has compressive force. So like compressive force, that means it is negative, right? We have already calculated that. So if you see this table, right, no doubt like we have done it previously, but this table is not required here. You should have only one table, this table, right? So like AD we got like 86.6 compressive. So compressive, that's how the negative sign is coming, right? Similarly, when we applied unit load, that time also we got like a minus value, right? Here we got minus value, compressive force, right? Since it is compressive, that's how we are writing like minus 0.577, right? So you should write down like force for each member. Then once you'll get this PK, all like substitute values here, and then you should calculate, as such you should calculate PKL by AE. But since again I am telling these three values are constant, so I am calculating only P and K, right? So like you calculate, you do the summation of all this value, say like negative, if it is negative then keep it negative, then algebraic sum you have to do, and then you have to substitute in this equation. So like if you substitute here, I told you this L, AE are constant, so they'll come out of this summation, and then like I'm substituting final value and I'm getting this final value as 1.99 mm. So this should be in downward direction. Why? Because we have assumed this unit load at C point in downward direction and we got positive answer. That means this 1.99 mm C point will deflect downward. So this is how you can solve the problem using unit load method to calculate deflection at particular joint. Now there is a home assignment. So this is problem of home assignment. This problem you have to solve, and whenever we'll have the next working class in our actual class, that time you have to bring this as a home assignment, or otherwise like you can submit it on Google class. That way also you can do. but I would suggest better you submit it on Google Class. This time you try to solve this one. And again, last time also I asked you one like derivation that you should do, that also you have to submit, and that derivation was this one: prove the Maxwell theorem by considering rotational force or moment. Right, so these two are the assignment that you have to submit on the Google Class. Right, so deadline I am keeping since you will be free at home, so I think 2 days are sufficient. So today is, again you are getting Saturday, Sunday in between, so next Monday, which day it will be, so whatever may be the day, so whatever may be the date, but next Monday is your deadline to submit this on Google Class. You must submit this on Google Class. So I'll evaluate only on the Google Class, right? So I'll generate like a question on the this Google Class. You have to submit it on the Google Class. Here, like force, what you have to consider is the last 3 digits of your roll number. Last 3 digits of roll number. So at C point, like somebody has roll number is 0.96, so they have to consider like this 0.96 force in kilonewton. So here at point B it will be 2 multiplied by 0.96, right? This much force you have to apply, so it will be 192 kilonewton you have to apply at B point, right? That way. But what you have to calculate is horizontal and vertical deflection. So here, like you have to calculate horizontal and vertical deflection. Again, you can understand because of downward force, the like deflection will be downward, so you should assume like 1 unit load in this direction. Another unit load you have to assume in this direction. Why? Because if this truss is rotating like this because of these 2 forces, then definitely this deflection will be in this direction. So 1 unit force you will be applying like this. So this truss you have to solve it for 3 times. 1 because of this 2 load, second because of say this first horizontal unit load, and third because of this vertical unit load. So when you apply this vertical load, that time you should not consider this horizontal force, and when you consider this horizontal unit load, that time you should not consider any other load, right? There should be only 1 unit load that should act at that point, right? So I hope you must have understood like what we have discussed. Even though if you have a problem, you can reply to me. Thank you.